Imagine a train that doesn't need wheels, doesn't touch the tracks, and still travels faster than a commercial jet. What if I told you Japan is spending over $55 billion to make that a reality? Building a high-speed train that will take passengers from Tokyo to Osaka in just 67 minutes? This is not science fiction. This is the Chuo Shinkansen Maglev line, one of the most advanced transportation projects on Earth, developed by JR Central Japan Railway Company. It's more than just another bullet train. This is a leap into an entirely new era of travel. The scale of this project is staggering. With a budget exceeding 7 to 9 trillion yen, about 55 billion US dollars, Japan is carving a new route through mountains, cities, and deep underground, connecting the major economic hubs of Tokyo, Nagoya, and Osaka. Once completed, this Maglev line will cover 438 kilometers, 272 miles across Japan's main island of Honshu. But what makes it truly revolutionary is the technology behind it, magnetic levitation, or maglev. Instead of running on rails like traditional trains, the maglev floats around 10 centimeters above the track, hovering using powerful superconducting magnets. With almost no friction, it can reach speeds of up to 500 kilometers per hour, 311 miles per hour, making it faster than most airplanes when you include airport wait times. Japan has long been a pioneer in high-speed rail, starting with the original Shinkansen bullet train in 1964, which connected Tokyo and Osaka in just over 4 hours and became a symbol of speed, efficiency, and safety. Over the decades, the Shinkansen network expanded, carrying millions of passengers every year, but it now faces serious limitations. The existing Tokaido Shinkansen line is overcrowded, especially during peak hours, and the growing demand for faster travel and increased connectivity between cities has put enormous pressure on the system. Add to that Japan's challenging terrain, frequent earthquakes and typhoons, and the need for a faster, more resilient, and advanced rail system became clear. This led to the creation of the Chuo Shinkansen Maglev line, a bold plan to connect Tokyo to Nagoya in its first phase, and eventually extend all the way to Osaka. The total route spans about 438 kilometers, 272 miles, most of which will pass underground through tunnels in the Japanese Alps, as well as bridges and viaducts across urban and rural areas. The train is expected to cut travel time from Tokyo to Osaka from 2.5 hours to just 67 minutes, effectively redefining intercity travel in Japan. The project isn't just about speed, it's also a statement of innovation and national pride. By investing over $55 billion, Japan is aiming to maintain its position as a global technology leader, demonstrate cutting-edge engineering, and create a transportation backbone that could inspire similar high-speed maglev networks worldwide. It's a marriage of ambition, precision, and technological prowess, designed to handle the pressures of modern life while showcasing what human engineering can achieve when money, expertise, and vision come together. The most fascinating thing about the Chuo Shinkansen isn't its speed, it's the way it moves. Unlike conventional trains that rely on steel wheels rolling on rails, this train floats above the track using magnetic levitation. Powerful superconducting magnets in the train interact with coils embedded in the guideway, creating a magnetic field that lifts the train about 10 centimeters off the track. With no physical contact, there's almost zero friction, which is why the train can reach speeds of up to 500 kilometers per hour, 311 miles per hour, and accelerate smoothly without the wear and tear that affects traditional rails. Maglev trains are also pulled forward by electromagnetic propulsion. The tracks generate a moving magnetic field, effectively pulling the train along the guideway without the need for engines or wheels to push it. In practical terms, it's almost like the train is hovering on an invisible cushion of magnetic force, gliding silently through tunnels and over bridges. During testing in 2015, the Chuo Shinkansen achieved a world record speed of 603 kilometers per hour, 375 miles per hour, proving that this technology isn't just theoretical, it works. The system also comes with extraordinary safety features. Since the train floats above the track, there's no risk of derailment from wheels leaving rails. The tracks and tunnels are engineered to withstand earthquakes, and the train's levitation system automatically adjusts in real time to maintain balance. On top of that, the train is far quieter than conventional high-speed rail, and its aerodynamic design reduces noise even at maximum speeds. In short, Maglev technology combines physics, engineering, and safety in a way that traditional trains simply cannot match, making it a glimpse into the future of transportation. Building the Chuo Shinkansen Maglev line is one of the most complex engineering feats in modern transportation history. Unlike conventional trains that run on open tracks, this Maglev line must pass through mountains, urban areas, and earthquake-prone zones, which means 85% of the Tokyo to Nagoya route will run underground. Engineers are constructing tunnels through the Japanese Alps, some stretching over 25 kilometers, and excavating millions of cubic meters of rock, all while ensuring minimal disruption to local communities and ecosystems. One of the biggest challenges is earthquake proofing. Japan is one of the most seismically active countries in the world, so every tunnel, bridge, and track segment is designed to absorb tremors and flex without damaging the train or guideway. Advanced sensors and real-time monitoring systems are being installed to detect vibrations and ensure immediate safety measures in the event of earthquakes or typhoons. Urban construction adds another layer of complexity. The line must navigate densely populated areas, requiring careful land acquisition, rerouting utilities, and minimizing noise and vibrations. Cutting-edge tunneling machines bore through solid rock and soft soil alike, creating a seamless path for the maglev while protecting buildings above. All of this contributes to the staggering cost of the project, over $55 billion, making it not just a transportation venture, but a national-scale engineering and economic undertaking. The combination of underground tunnels, bridges, high-tech tracks, and superconducting systems pushes the limits of modern civil engineering, setting a benchmark for future mega-projects around the world. The Chuo Shinkansen Maglev line comes with a staggering price tag of $55 to $60 billion, making it one of the most expensive train projects in history. But when you break down the costs, it becomes clear why. First, there's the tunneling through mountains and urban areas, which requires advanced machines, reinforced concrete linings, and extensive safety measures to withstand earthquakes. Unlike above-ground rail, underground construction adds massive complexity and time, dramatically increasing expenses. Second, the maglev technology itself is extremely costly. The train uses superconducting magnets cooled with liquid helium to near absolute zero, high-tech propulsion coils embedded in the tracks, and precision guideways, all of which require specialized materials and maintenance. The track and train must be built with micron-level precision, because even the smallest misalignment at 500 kilometers per hour could be catastrophic. Land acquisition in Japan's densely populated cities is another significant cost driver. Developers must negotiate with private landowners, relocate infrastructure, and compensate residents, often at premium urban rates. Additionally, environmental mitigation, such as river protection, noise barriers, and ecological preservation, adds tens of millions of dollars. Finally, the maglev system requires state-of-the-art control centers, monitoring systems, and emergency mechanisms to ensure passenger safety at unprecedented speeds. Despite the high initial investment, JR Central expects long-term benefits: reduced travel time, increased passenger capacity, energy efficiency, and a global showcase of Japanese technology that could inspire future high-speed rail projects worldwide. The Chuo Shinkansen Maglev line isn't just about getting from Tokyo to Osaka faster. It could reshape the way we think about transportation globally. By cutting travel time from 2.5 hours to just 67 minutes, the Maglev makes city-to-city travel competitive with air travel, especially when you factor in airport security, check-in, and boarding times. For business travelers, it offers the convenience of city center to city center transport at speeds previously unimaginable. Beyond Japan, the project could inspire high-speed maglev networks worldwide. Countries like the United States, China, and Germany are already exploring maglev systems, and Japan's success could serve as a blueprint for connecting major cities efficiently and sustainably. The line also has environmental benefits. Replacing short-haul flights with high-speed maglev could cut carbon emissions, making it a greener alternative in the era of climate change. However, challenges remain. Ticket prices will likely be higher than conventional Shinkansen fares, potentially limiting accessibility. There's also the question of Japan's aging population. Will demand be high enough to justify the enormous investment? Despite these concerns, the Chuo Shinkansen represents a major leap forward in speed, safety, and technological sophistication, offering a glimpse of a future where cities are connected in ways we once only imagined in science fiction. So is Japan's $55 billion Maglev train the future of global travel, or just the world's most expensive experiment in speed? With its ability to float above the tracks, reach speeds of 500 kilometers per hour, and cut Tokyo to Osaka travel to just 67 minutes, it's clear that this project is pushing the boundaries of engineering and technology like never before. But it's more than just a train. It's a statement of ambition, innovation, and Japan's commitment to shaping the future of transportation. Whether it becomes a blueprint for other countries or remains a uniquely Japanese marvel, one thing is certain. Maglev technology is changing the way we think about moving across the planet. Would you ride a train faster than a jet? Comment below and don't forget to like and subscribe for more videos on the world's most incredible mega projects.